So, hello everyone. In the last class, I have discussed about the chapter work, energy, and power. Okay. So, in that chapter, I will discuss some other topic which will remain of that chapter and important question, previous year question of this chapter. Okay. This will be the last part of the chapter. Okay. Now, what we have the topic? Our first topic today is power. So, what is power? Power is defined as the rate of doing work. So power is defined as the rate of doing work, which means the power is equal to work done upon time. Power is equal to work done upon time. It is a scalar quantity. It is a scalar quantity because work is a scalar, time is a scalar. So that's why power is a scalar. And the dimensions of work is ml to t minus 3. Dimensions are ml to t minus 3. And the SI unit of power is watt or joule per second. Watt or joule per second. Okay. Now, remember the one more power of work, one more unit of power. First is kilowatt. Kilowatt is 10 to the power 3 watt. And what is 1 horsepower? Horsepower is equal to 746 watt. Many of time that question comes in your short answer type question. Derive the relation between horsepower and watt. So 1 horsepower is equal to 746 watt. Now come to the next topic. With that was instantaneous power. Instantaneous power. So what is instantaneous power? So rate of doing work at particular instant of time. At particular instant of time. Power is defined as limit delta t tends to 0 change in work done upon change in time. So we can simply say that the dw by dt is known as the power. Instantaneous power means which is for a very short duration. Okay, instantaneous means very short duration. So work done, change in work done upon time, and dw is f dx upon dt. So dx upon dt is change in velocity, change in displacement upon time, which is equal to velocity. So power equal to force into velocity. Okay, so that was the relation between power and force. Now come to the next topic. That was your collision, and the last topic. After that, I will discuss some important question which we have come in your previous year. So, topic is our collision. What is collision? When two bodies strike with each other, they exert a large force on each other, and that phenomenon is known as the collision. This two bodies will collide. This is collision. So, what is collision? When two bodies when two bodies strikes with each other, strikes with each other, they exert large force on each other. They exert large force on each other. This phenomena, this phenomenon is known as collision. Is known as collision. Now suppose firstly that was a body A which was moving with velocity u1 and body B which was moving with initial velocity u2. After collision, they will collide. That was during collision. That will collide with each other. And that was before collision. Before collision. Before collision, u1 is greater than u2. And after collision, what will happen? A move with velocity v1 and B move with velocity v2. That means v2 is greater than v1. The velocity will be transferred. Firstly, before the collision, which body will move fast? Uh, After collision, that body will move slower. And before collision, which body will move slower? So after collision, that body will move faster. Now, next is types of collision. Types of collision. Firstly is elastic collision. So what is elastic collision? The collision in which there is a no loss of kinetic energy. So what is elastic collision? The collision in which there is a no loss of kinetic energy. The collision in which there is no loss of kinetic energy is called elastic collision. Is called elastic collision. When there will be no loss of kinetic energy, that collision is known as the elastic collision. Now suppose that was body A moving with velocity u1, second body B moving with velocity u2. After that they will collide and A move with velocity v1 and B with velocity v2. Okay. So before collision their velocity will be half m1 u1 square plus half m2 u2 square. And after collision they have velocity half m1, sorry, kinetic energy half m1 v1 square plus half m2 v2 square. So a collision in which the initial kinetic energy is equal to the final kinetic energy, that type of collision is known as the elastic collision. Okay. So what are the properties of the elastic collision? So the properties of elastic collision. First property is momentum is conserved. Momentum is conserved in all type of collision. Okay. Momentum is conserved. Main point is that the kinetic energy is conserved in elastic collision. So kinetic energy is conserved in elastic collision. That was your important. Okay. Third one, if kinetic energy is conserved, total energy is also conserved in any type of motion, in any type of collision. So total energy is conserved. Last one, forces involved during the collision are conservative. Forces involved during the collision are conservative. During the collision are conservative. Okay. Now, second one is your elastic collision. The collision in which the some loss of kinetic energy will be there. Okay. Second topic is your inelastic collision. Inelastic collision. So, what is inelastic collision? The collision in which there is loss of kinetic energy. The collision in which there is loss of kinetic energy. So that type of collision is known as the inelastic collision. So what are the properties of the inelastic collision? Firstly, I will draw the diagram. Okay, so suppose that are two bodies. The body A moves with velocity u1, the body B moves with velocity u2, and during collision they are stick together. After the collision, A move with velocity v1 and B move with velocity v2. So the kinetic energy will not be equal. Kinetic energy before collision will always greater in that case. Collision is greater than kinetic energy after collision. Okay. So the properties of inelastic collisions are: firstly, same momentum is conserved. Momentum is conserved. But one of the thing is not conserved here. That was kinetic energy. So kinetic energy is not conserved. Third property, total energy is also conserved. Total energy is conserved. Fourth one, some or all the forces included in inelastic collision may be conservative. May be conservative. Now next is perfectly inelastic collision. Perfectly inelastic collision. So what is the perfectly inelastic collision? If two bodies stick together after the collision and move as a single body, the move with a single common velocity, then the collision is known as the perfectly inelastic collision. So what is perfectly inelastic collision? If two bodies stick together after the collision and move as a single body and move as a single body with common velocity, with common velocity, then then collision is known as perfectly inelastic collision. Okay, now take the example. Suppose that was body A move with velocity u1, that was body B move with velocity u2. After collision, during collision, they will stack together, and after collision, they will move with the common velocity v with stick together. That is known as perfectly inelastic collision. That was before collision, during collision, during collision, after collision, and last case was of after collision. Now all the topic is discussed. If anything is left, and that was important for your exam point of view, so we cover it in a question form. Okay, so now I am discussing important question that have come in your previous year of that chapter. Okay, wait, just a wait. question number 1 is state and proof law of conservation of energy, law of conservation of energy in case of freely falling body, in case of freely falling body. Okay, that was your first part. And the second part is that required a pump is required to lift 600 kg of water per minute from a well of 25-meter deep and to eject with a speed of with a speed of 50 meter per second. Calculate the power required to perform our tasks, to perform above task. Now, first is state and proof law of conservation of energy. So, what is law of conservation of energy? Law of conservation of energy state that energy can neither be created nor be destroyed. Only it can be transferred from one body to another body, or you can say that total energy remain the constant in every part of your body, in every motion of the body. Okay, simply you can firstly had the law of conservation of energy state that energy can neither be created nor be destroyed. Only it can be transferred from one form to another form. Now, in the case of freely falling body, I have discussed it earlier. So, what is the case of the freely falling body in which we have taken 3 points? That was the case of freely falling body. So, energy in the freely falling body, you can simply say that the energy, conservation of energy in freely falling body, conservation of energy, conservation of energy in freely falling body, in freely falling body. I have discussed in the previous video that a body at point A is first is taken at surface is taken at height h from the surface of Earth. So at point A, it have zero kinetic energy because it have it is at rest, so it have zero velocity. Okay, it only have its potential energy mgs. So total mechanical energy will equal to the sum of kinetic energy and potential energy. So 0 plus mgs is equal to mgh. Now at point B, it was at height h minus x, so its potential energy will be mg into h minus x, but the kinetic energy will be half mv square. So when it falls from point A, it has covered h distance from point B. Okay, so at point B, if we apply the third equation of motion, v square minus u square equal to 2as, so we will get v square equal to 2gx. So the kinetic energy will be half mv square and v square equal to 2gx. On cancelling, we will get mgx. So the total energy will be potential energy plus kinetic energy. Potential energy mg into h minus x and kinetic energy mgx. If I take mg common, so h minus x plus x, mgh will be the answer. Okay. Now come at point C. At point C, means at the surface of Earth, potential energy of Earth is zero and it have only kinetic energy. So from point A to C, it has covered a distance h. Okay, so on applying the Newton's third law of motion, so you will get v square minus u square equal to 2as. Initial velocity is zero, it have covered distance h and with acceleration g. in the motion of a body is downward and acceleration due to is downward. That why I have taken acceleration as positive of g. Okay, so v square equal to 2gh. So at point c, potential energy is 0 and kinetic energy is half mv square. V square equal to 2g. On cancelling, you will get mgh. So the total mechanical energy will also the sum of the kinetic energy and potential energy. So we will get mgh as an answer. Okay, so if we have seen that at point A, B, and C, at all point A, B, and C, we have getting same total energy, mgh. So that was the law of conservation that was following the law of conservation of energy when a body falls freely. Okay, so you can write that case. Now come to the next part. A pump is required to lift 600 kg of water per minute from a well of 25-meter deep and to eject with a speed of 50 meter per second. Calculate the power required to perform above task. Now come to the second part. What the question is saying that the mass of a body is 600 kg and height of tanker is 25 meter and velocity is 50 meter per second. It is flowing with a velocity 50 meter per second and time required. What is the time required in it? Calculate the power required to perform above task time and to eject with a speed of 50 meter per second. Calculate the power required. Okay, of all things is given in seconds, so take it as 60 second. We have to take calculate it in the 1 minute. So power is equal to work done upon time, and work done is a sum of, we can say the work done is energy upon time, and energy is a sum of kinetic energy plus potential energy upon time, because it is at height h and it is flowing, so it has both kinetic energy and potential energy. Kinetic energy is due to the flow of motion, flow of water, and potential energy due to its configuration at height h or its position at height h. So the kinetic energy of the body will be half mv square and the potential energy is mgh upon t. Now, if you take m common, so you will get v square by 2 plus gh upon t. Okay, you have to take g as 9.8. So m is 600, time is 60, gh. G means 9.8 into height is 25 meter plus v square 15 to 50 by 2. So on solving, you will get 10 into 245 plus 1250. On solving, you will get 14950 watt as an answer, or you can say that 14.995 kilowatt is the power required. Okay. Okay, just a minute. What are collisions? So now come to next question. Next question also your long answer type question of your section C. So what are collisions? What are collisions? Explain the type of collision. Show that in the case of one dimensional elastic collision, in a case of one dimensional elastic collision, the relative approach, the relative velocity of approach of two colliding body before collision is equal to the relative velocity of separation after collision of separation after collision. Okay. So first type is what are collision. I have discussed it earlier in previous video. And what is the type of collision? So I have discussed these two topics in the previous video. So firstly, what is the collision? When two bodies are stacked with each other, they exert a large force on each other. This phenomenon is known as collision. Means the two bodies moving with velocity u1 and u2 after they will stack with each other, collide with each other, and after collision they will move with a different velocity. That is known as the collision. Okay. Now, secondly, I have discussed about the elastic collision in which the kinetic energy is conserved. So that type of collision is known as elastic collision because the momentum is conserved, total energy is conserved in all type of collisions. Okay. And the force involved during the collision are conservative in elastic collision. And in elastic collision, the collision in which there is a loss of some kinetic energy, so that type of collision is known as inelastic collision. Okay. So kinetic energy is not conserved in inelastic collision, or some or all the forces included in inelastic collision may be conservative. Okay. So next is perfectly elastic collision in which two bodies are stacked together after the collision, so that is known as inelastic collision. Now two part is clear. Come to the last part is saying that explain that in the case of one dimensional elastic collision, the relative velocity of approach of two colliding bodies before collision is equal to the relative velocity of separation after the collision. Okay. So I have to prove that part. So take elastic collision in one dimension. Suppose that was the body A have velocity u1, second body B have velocity u2. After collision, they will strike together. After collision, A move with velocity v1 and B move with velocity v2. So this is after before collision. This is during collision. This is after collision. So first thing is momentum P is conserved in all type of collision. So in that case, P is also conserved. That means P initial equal to P final. So M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Now take one term one side, M1 U1 minus M1 V1 equal to M2 V2 minus M2 U2. Now if I take M1 common, so I will get U1 minus V1 equal to M2 common U2 minus V2. That was equation first. In elastic collision, Ke is also conserved. Ke is also conserved. So what will we get from here? If Ke is conserved, so what will happen? So initial kinetic energy is always equal to the final kinetic energy. What is initial kinetic energy? Half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. Now take one side the term common m1 m1 and m2 m2. So half m1 u1 square plus half m1 v1 square minus m1 v1 square minus minus half m1 v1 square equal to half m2 v2 square minus half m2 u2 square. Now take half m1 common, so you will get u1 square minus v1 square, and half m2 common, v2 square minus u2 square. Now half will be cancelled. That was equation second. Dividing equation second by equation first. Dividing equation second by equation first. So what will you get? Equation second is m1 u1 square minus v1 square, m1 u1 square minus v1 square equal to m2 v2 square minus u2 square, v2 square minus u2 square. And equation first is m1 u1 minus v1 equal to m2 v2 minus u2. Now m1 will be cancelled, m2 will be cancelled. So on denominator a square minus b square, you will get u1 minus v1 and u1 plus v1 upon u1 minus v1, and here v2 minus u2 and v2 plus u2 upon v2 minus u2. So that term will be cancelled. So u1 plus v1 equal to u2 plus v2. So what will we get? u1 plus v1 equal to u2 plus v2. Okay. So u1 minus u2 equal to v1 minus v2. What is u1 into u2? Relative velocity of approach. Relative velocity before approach or before collision. And v2 minus u2. Wait, just a minute, just a minute. I have written equation wrong. Sorry for that. u1 minus u2 equal to v1 v2 minus v1 equal to relative velocity after approach. Relative velocity after approach. After approach. Or you can simply say that relative velocity, okay, before collision is equal to after collision. So that we have proved that before collision is equal to the relative velocity of separation after the collision. Okay, so that question is done. Come to the next one. Now come to the next question. That was also of your section C. That means five number question. Develop the motions of work. The motions of work and kinetic energy, and show that it leads to work energy theorem. Work energy theorem. So first is develop the motion of the work. Means it was saying about the types of work done. Firstly, you have to define that what is work and what are the types of work done. Then kinetic energy. then you have to show that work energy theorem. I also have discussed it in the previous video. Firstly, that what is work? Work is defined as the scalar product of force and displacement. Just a minute. So that work is said to be done when a force is applied on a body and it displaces a body. So that is known as your work done. Yeah, just okay. Now the motion of work. So motion of work is when the both force and displacement are in same direction. So that was the case. And when it is inclined at an angle, so that was the case. Okay. Now second was is your energy. So what is the energy? I have also defined as energy. Sorry, second one is your kinetic energy. So kinetic energy is defined as the energy possessed by a body by virtue of its motion is known as kinetic energy. I have given you example, and now you have to prove the work energy theorem. Work energy theorem states that the change in kinetic energy of a body is equal to the work done uh, by the body. So work done is equal to change in kinetic energy. So there will be a proof. This is a normal algebraic method, and the second one is your calculus method. So prefer calculus method over there because on the calculus method, you will get maybe you will get extra preferenceable marks. Okay, okay. Now, this question is also discussed by me. Now wait for next question. Again, your 5 number question. State the law of conservation of energy. State the law of conservation of energy. Law of conservation of energy and verify in the case of freely falling body. And verify in the case of freely falling body. Case of freely falling body. Okay. First part is that I have discussed it earlier, and now second part is calculate the power of a pump required. The power of a pump required to lift given to lift 600 kg of water per minute from a well of 25-meter deep. Well of 25-meter deep. Okay, that both question I have discussed earlier. Okay, now come to the next question. If any question is left. Now same question is there. The state and proof law of conservation of energy. And second question is, I am writing only second. First question is same state state and proof law of conservation of energy in a freely falling body. That was very important for your exam point of view, huh? Now, second question is a machine gun fires a machine gun fires 360 bullets per minute. A machine guns fire 360 bullets per minute, and each bullet wait 1 minute 1 minute. And each bullet travels with a velocity of with a velocity of 600 meter per second. If the mass of each bullet is 5 kg, sorry, 5 gram, if the mass of bullet is 5 gram, find the power of machine gun. Find the power of machine gun. Now come to the solution of the second part of a gun fires 360 bullets per second. So here the number of bullet is 360. Okay. And time is 60 second. This per minute means 60 second. Now second is yes velocity. Velocity is 600 meter per second. Okay. And the mass of the bullet is 5 gram. Converted it into the kg. So you will get 5 into 10 to the power minus 3 kg. Now the power. Power is work done upon time. Here work done is also known as the energy in time. And which type of energy is there? Kinetic energy. So half mv square upon t. But here are n number of bullets, so I will take n. Okay, so what is the value of n? 360 into 1 upon 2. Mass of each bullet is 5 into 10 to the power minus 3. And second, the velocity will be 600 into 600. So on solving all the value, you will get answer as 5400 watt, which is equal to 5.4 kilowatt as your answer. Okay. So that's all for today. Now, in the next part, I will discuss one or two more question of that chapter, and after that, we will discuss our next chapter. Okay, so that's all for today. If you have doubt in any topic of this chapter or in any question, so you can send that doubt or question to sir or ma'am. They will forward me, and I will solve that part in your video. Okay, that doubts and part in your video. Okay, thank you everyone. That's all for today.